Hello and welcome back to another video. In this problem, we're told that a stone is dropped into a lake, creating a circular ripple that travels outward at a speed of 60 centimeters per second. So in part A, we're asked to express the radius r of this circle as a function of time t. So what does that look like? Well, we have this function, right? We can call it f. It is a function of t. And to construct this function, we have to think about what kind of function it is, right? So we have a circular ripple that travels outward at a speed of 60 centimeters per second. That means that the radius is going to be a constantly increasing at a constant rate function. So that means that it's a linear function. And we have our rate of change right here, 60 centimeters per second. Every second, the radius increases 60 centimeters as this circular ripple travels outwards. So if it's a function of t, then we can do the slope-intercept form. So it's 60, the slope, times t. And then we can do this plus the y-intercept. So what is the y-intercept? So it's the value of y, which is f. So it's the radius when x, or t, is equal to 0. So it's the radius when time is equal to 0. Well, time is equal to 0 when the stone is dropped into the lake, at which point there is no radius. It's equal to 0 because it's just been dropped in, and the ripple hasn't gone outwards at all. So this is 60t plus 0, or just 60t. Next, if a is the area of this circle, as a function of the radius, find a of r and interpret it. So what we have to do here is take r, which is really what we should have called this original function, right? Because that's what they're asking for. The radius r of this function is 60t. If the area of this circle is a function of the radius, find a of r. A of r of t is the area of the circle. Well, what is the area of the circle? Well, it's the radius squared times pi. So what is this? Well, we actually have to plug in what we have for the radius. So that's pi times 60t squared. 60 squared is 3,600 pi, and then t squared is just t squared. And this is the composition here in terms of t. What does this actually mean, right? We're asked to interpret this. Well, this is the area as a function of time. So at any given time, in the seconds since the stone was dropped into the lake, the area is going to be 3,600 pi t squared. This is in centimeters squared for area, and it is the composition of this function.